Good morning, everybody. Happy Friday. Good to see you all here. I know everyone's kind of tired, ready to kind of get out of here. So this is managing laps with Catalyst. If you don't know what those terms mean, we'll get into it in a second. Before we kind of get into the weeds here, just a quick bit about me. My name is Henry Kahn. I'm based down south in Cary, North Carolina. I'm a recent grad from NC State with a bachelor's in science, technology, and society, and I'm working on my MBA currently at Capella University. I've been Microsoft certified on the Azure platform since 2022, and I've been working on enterprise IT at some level or another since around 2018, back when I was working in hardware support for a large area hospital system. I've been through basically the entire gamut at this point, from those kinds of restricted, really big healthcare environments with interesting compliance requirements to smaller startups, game studios, small businesses, all the way over to my current role, kind of somewhere in the middle with SaaS Institute. Now, if you haven't heard about us, I really can't blame you. I like to say we're the largest company you've never heard of. We are one of the largest data analytics software firms on earth. You could probably call us one of the OGs in the field. We've been doing this since the 70s. We do business with most of the Fortune 500 and a solid number of national, state, municipal governments. I've been here since I started as an intern in 2022, working on our enterprise client management team. So we design and maintain solutions to manage our internal client computing fleet of over 30,000 devices for over 13,000 global employees. I transitioned to full-time at the end of 2024, and my focus is on engineering solutions that we can't really find off the shelf for one reason or another. Usually it's because of product cost or a market gap. I also work on driving endpoint security projects with user experience in mind. So think Windows Hello for Business or endpoint privilege management, where we separate administrative privileges from the actual device user. I spent most of my career on the Windows side of the house, working with those older on-prem technologies like Active Directory and System Center, and I've since upskilled into Intune during my time at SaaS. I've moved into more of a general cross-platform role over the last 2 or 3 years, though, and I'm currently wearing both the Windows and macOS hats at SaaS, kind of driving projects to bring those two platforms a little bit closer to management and experience parity. All right, so got that dense introduction out of the way. So before we go any further, I did want to make a quick clarification about what exactly Catalyst is and the whole concept of laps for those of you who may be a bit newer to this sort of technology. Maybe you haven't had a compliance need to kind of do this before, what have you. So first off, this is not related to the Apple Catalyst framework for running iPad apps on the Mac. Probably a bit of an unfortunate name choice on my end, but I didn't know about Apple's Catalyst framework, and by the time somebody told me, I had already set up all the signing certificates. It's a huge headache to get all that changed. So this is what we're stuck with. If you've ever watched Silicon Valley, it's kind of my Pied Piper moment here. I've already bought the shirts. So that's what we're stuck with. And secondly, especially if you don't have any sort of privilege management software in your environments already, you might be wondering, well, what the hell is laps? So basically, if you want to separate administrative privileges on the device from the actual user, you still need a admin user on that device. And so it's an OS level restriction. You can't get around it on really any OS. So the next question becomes, how do you store the password for that account without giving the user unfettered access to it, which basically defeats the point. And that's where the entire concept of this LAPS or local administrator password solution comes in. And basically, it's a system for keeping that password rotated and stored away, but available to your IT team so that they can give it to the user or use it in a remote session if they need to break the glass and use the account to complete an elevated action. So there's a couple different solutions on the market currently for macOS devices specifically. Of course, Jamf does this out of the box because, well, it's Jamf. But you might not want to use Jamf. Your employer might not want to get the extra licensing. They might already have Intune. That's kind of the boat we're in. There's a couple open source solutions available in various states of maintenance or support to kind of meet this need. So the big one is macOS Laps by Joshua Miller. We've been using that at SaaS since we moved to Intune in around 2021. So getting into that some more, how are we using macOS Laps, and why did I get so fed up with using it that I spent a year building something else? So on the face, deploying macOS Laps is rather simple. You deploy the client software to the device using your endpoint management software of choice, so like Monkey or Intune. Throw a script in to create the admin account, kick off the system, you're done. But macOS Laps only handles rotating the password on the device and it gets stored in the system keychain, and then after that, picking up the password and storing it somewhere usable is kind of up to you. The way we do it is we deploy a canned script that's included with macOS Labs as a custom attribute in Intune. So essentially what Intune will do is run the script on the device and then just take the script output and put it into the device record as a custom attribute. And if you don't quite get the custom attribute bit, we'll get to that in a second. So it sounds pretty simple, right? Install on the device, grab the password, put it somewhere. What could possibly go wrong, right? Well, turns out a lot. So the big thing is that this is actually a lot of moving parts when you think about it. You have to run a script to lay down the admin account, then install the macOS Labs software, then use the completely separate custom attribute script to pull that password out and store it somewhere usable. Now, if you're using Intune at all to get that password out, well, I've got wonderful news for you. Intune only typically syncs with the device every 8 hours. So I've had my friends at Microsoft call it the speed of Microsoft. You probably heard that before. I've basically stolen that at this point. So let's say the password rotates somewhere during that 8-hour communications blackout, and your custom attribute still has that old password there. Well, user gets on the horn, hey, I need to do this thing, and I need the admin password. Hey, the privilege management is broken. I need the password to install Xcode, or something like that. So your help desk will go, and it'll grab that old password, and they'll give it to the user. Well, what's going to happen? It's not going to work. So now your support staff is stuck. Your user is stuck, and they're probably not particularly happy right now. And now it's just a whole mess. So you can't tell the user to just wait 8 hours. It's a poor experience for everybody, and who's to say it won't rotate again in the meantime? But it gets, oh, well, okay, sorry. I am on the right slide, okay. It gets worse though. So let's say that the user gets so frustrated that they just throw up their hands and proclaim, IT couldn't help me, I'll figure this out myself. So they'll sniff around on their machine and try and figure out what's going on, what's keeping them from that sweet, sweet admin password, and they figure out you're using macOS Labs. Well, that's one Google search away from the GitHub page with the exact canned script you just used to pick up the passwords, and guess what? The password is stored in the keychain in plain text. So sure, you need elevated access to kind of run the commands to extract it, but if the user is a developer, we can assume you've given them some degree of elevated access already anyway, otherwise they'd be breaking down your door every 8 minutes. So with that access and the exact canned script that you're using in hand, the user basically has a treasure map right to the password. There's no additional protections on it, and if you can somehow get to the var root directory and read out the contents of that generated lapse service name file right here, well, then you have yourself an admin password. Now your user's running around with the admin password you didn't want them to have, and now they have the knowledge and the ability to go and tell all their friends about it. And at this point, you may as well have not even bothered. And if you thought that was bad, oh boy, any attacker manages to escalate privileges once and they figure out how to get this out, you've just handed them a free key to the device. My advanced button doesn't work. There we go. So that's the user perspective. So I'm not particularly confidence-inspiring. But unfortunately, I can't say it's much better on the service provider side either. Your help desk obviously needs access to these keys for the break glass scenarios. That's a given here, no way around that. Well, now they have complete, unrestricted, and unaudited access to all device passwords, since they're all clumped into the same custom attributes panel in Intune. So there's no way to gatekeep it. There's no way to monitor what they're accessing in there. So let's say one of your help desk staff falls victim to the all-reliable phishing email. Nothing to be ashamed of. It happens to all of us. They get your security office involved. They regain control of the account. Okay, great. Well, now you've just allowed an attacker to run around in your environment for whatever amount of time it took to report that breach and remediate it. So you better hope they didn't figure out how to get those local admin passwords, because if they did, and you will never know if they did since there's no auditing, you have no idea which devices, how many, or even if at all, they were able to hoover those local admin passwords from. So what does that actually look like? Well, you'll be doing your thing, all cool and good, till your information security guys roll up. And the conversation will go a bit like this. Someone in the help desk had their account compromised. Did they access any of the local admin passwords? Well, now what? You can't lie to them. Your answer ends up being, I have no clue. I'll be honest, not the best look for your security posture. And let's take it from a different angle. No breach here, breathe a sigh of relief. Well, new problem. If your company does any sort of work with governments or high security clients, like banks or healthcare, clinical type places, you're probably familiar with our favorite buzzword, our favorite time of the year, the information security audit. So there's a ton of different types of audits, different types of auditors, Cyber Essentials, ISO 27001, audited by a variety of people, KPMG, Deloitte, Accenture, the list goes on. They do a ton of different things, but they're basically around to make sure that you're keeping things secure and prove that much to the clients you're working with. Usually, at the very least, it's a rather invasive questionnaire. They're going to want to make sure that you've got a handle on privilege management. Users being on admins on company devices is a big no-no in these kinds of cases when you're working with especially risk-averse clients. So you'll get asked if you're properly separating that control out. Well, duh, you say, checking the yes box, and then they'll hit you with this doozy. Are you storing these local administrator credentials securely, at rest, and in transit with proper access controls? Well, on the device, I guess they're reasonably safe. You need to have another way to escalate privileges to get to that password on the device. In transit, Intune encrypts it, I think. We're good. But what about on the service provider side? Well, crap. You don't have any way to monitor who's accessing what, and your access controls don't let you completely restrict access the way you need to. So it looks like you have to check the no box. Well, I think that's what the auditors call a finding. And now they have to tell your company's client, hey, these folks aren't compliant. Now it's a headache for you, it's a headache for everybody, and the client is unhappy because their vendor doesn't have their stuff together. So it looks bad for everybody. Hydration's important, people. And this is all assuming that everything's working the way it should on the device. So you deploy and run the software assuming it's all good, everyone else is using it, it's going to be fine. Well, let's circle back to how that password is stored on the device. macOS Lapse will generate a random password, store it in the keychain, and it just sits there till a script comes and reads it for you. Well, how's it storing the keychain object? It's force unlocking the system keychain and then storing the secret in an object in there. Okay, great. Well, Apple doesn't really want you to do that. They don't like applications kind of picking and choosing what keychains they go to like this, especially the old ones. So these two function calls to the keychain, sec keychain open and sec keychain unlock, have actually been deprecated since macOS 10.10 all the way back in 2014. Okay, great. Well, it's still working, right? I mean, yes, most of the time, until Apple removes it without telling anybody, just the same way that they deprecated it. So your critical piece of security tooling is broken. You might not know why because you're busy and you don't have time to go find that. And, well, I guess it's time to start over, isn't it? So one way or another, something breaks or the keychain object gets corrupted because it's being manipulated with deprecated function calls. We've seen that occasionally. So macOS Lapse on some devices will simply stop working or forget the password. And when that happens, you get one of these fantastic error messages here where there should be a password. So usually that happens when the admin account has a secure token enabled, but the behavior here is really inconsistent. But how it happens doesn't really matter here. The bigger problem is, well, how do you fix that problem machine? Well, easy. I'll just go get the device from the user, remote into it, put in the admin password, and reinstall the software. Hold on a second. I don't have the password anymore because custom attributes don't store output history. Your password has now just been overwritten by this error message. So unless you have some other way to get elevated access to the machine, like a failsafe on top of the failsafe, you're stuck now and the device has to either be reset or you need to do some song and dance with your MDM to reinstall that lapse software from scratch. And now for the salt in the wound. That's right, there's more. So let's say you're a help desk worker, Mac user calls in, hey, I need the admin password, I need it yesterday, give it to me now. Okay, not too terribly time consuming. You just go to Intune and you go to devices, go to macOS, find this little custom attributes button, hiding all the way down there. Y'all still watching? We're about halfway there. So you're in custom attributes, you have to select the right one. If you're lucky like we are, we have just the one or it's named something really obvious. And then you just hit device status over here, and you're finally greeted with this big old pile of passwords for all your Macs sitting here in plain text. So you punch the device name in that search box there, and you wait about 80 years for the search to load, and you can finally give the password to the user after resizing all those columns so you can actually see the password. I'm sure the fine folks in the help desk absolutely love this workflow. So I've tried to be a bit humorous here, kind of laying out the unique challenges, kind of hoping that came across the way I wanted it to. But for what it is, macOS Labs is honestly pretty decent if you just need something now and you don't happen to have a fleet of developers to build something else. So great for small businesses, that type of thing, where you can keep a close eye on your device fleet, but when you scale it up, it starts to become a little bit less workable. So now you know where my mindset was about a year and a half ago when I started working on this problem. It took a couple of fits and starts, several rewrites, kind of exploring ideas out here, but here's the solution I was able to come up with. You're going to love this. Copy Windows. Well, sort of. Well, no, I guess not really. So after trying to figure out how to make things work for about a month, I remembered that until around 2023, folks using Windows with Intune kind of had a similar problem. How do we keep these credentials up to date and secure? And out of that, a couple enterprising gentlemen ended up taking that problem and building a solution for the Windows platform, and that's what ended up becoming Cloud Labs. It's a cloud-native way to manage local admin credentials on Windows devices while maintaining auditability and ease of use. It hasn't been maintained in a while, but it still works fine for the task. It's just fallen out of wide use on the Windows side since Microsoft added native labs to Intune. But everything still works. It just needs a little bit of adaptation to work on macOS. So this is actually what became the ace up my sleeve to make this work. So how does Cloud Labs work then? And don't worry, don't take notes on this. It's more just here as a visual aid. Well, the way it works is you have the client device down here, and it'll reach out to the Labs server saying, hey, I need a password. And the way it works on Windows is you use a PowerShell script to do this. We'll get into why that doesn't really work in a minute. But what happens is the server will validate the device with Azure. It will generate a local admin password and store it in a key vault, and then send it down to the device. And then the device sets the admin account to that password, you're good to go. And this server-driven approach comes with a couple key advantages. The biggest one being that instead of relying on the client software to generate the password and then using some extra logic to basically interrogate the device for what it thinks the password is, the server manages the entire process, so a password can't get lost in the entire workflow. After all that, your password is immediately stored in an Azure Key Vault, and you may be wondering, well, what on earth is that? Just use a database or something? Well, it's like a database, but if you gave it a sword and an elephant's memory. Key vaults are basically purpose-built for storing sensitive data like this, so credentials, certificates, passwords, you get the picture. They're able to use granular network and user access controls to lock access down to only the services or users that need to access it. So you can restrict what networks access it, even down to the IP level. And the really cool thing with these is that they keep a history of old values for all the secrets in the vault. So let's say the Cloud Labs server sends down a password, but for some reason the device doesn't apply it. With a traditional database, you're out of luck, where if you have custom attributes, well, we've already seen how that goes. But with the Key Vault, that old value will always be there, and you can always recover it. So there's also some other helpful kind of security and quality of life improvements with Cloud Labs. Namely, the service provider and administrator experiences are way more usable. So no more hunting for the custom attribute, no more wondering who's accessed what and when. And the entire deployment into Azure is dead simple. So this is what you see on the administrator side. This is a monitoring workbook that comes with Cloud Labs. All of this is built right into Azure. So you can pin it in the Azure portal, jump right back to it whenever you need to. So you can see the number of unique devices checking in up here, and then what their last status was down here, and just a nice clean way to kind of keep an eye on deployment health. Now you're probably asking, well, that's great. How does that solve the auditing issue you were just squawking about a minute ago? Well, I'm glad you asked. Because in that same workbook, there's a tab for monitoring admin password retrievals. So when your help desk staff or other engineers that you've given access go and grab a secret, it shows you pretty directly who got that secret and when. So your security office says, hey, what devices did John Doe or Henry Kahn over here pull the passwords for, and when? Well, it's all a quick search away. And the help desk or service provider experience is way easier too. Cloud Labs comes with a custom portal that deploys right into Azure, along with the rest of the infrastructure, integrates with Entra ID single sign-on, so no additional logins to remember, and it drops you right into an easy search tool to quickly find what you're looking for. You can easily restrict who can access this portal using Azure's built-in access control tools with the ability to add individual users or entire Entra ID groups. So if you have a group already for your help desk staff that's pre-populated, you can just throw that in, you're done. The best part is, no more waiting for Intune to pick up the password and put it somewhere. The password is always stored securely first, with the process being near instant. And points if you got that Easter egg up there. So sounds like a pretty sweet package, right? I mean, definitely a great solution to the use case here. Just one small snag, though. The PowerShell scripts that this was originally designed to use don't work on macOS. And there's a couple other small hiccups that we'll get to in a minute. So as one does, I learned Swift and ported the entire client system to macOS. So I had a pretty decent framework to start from with the PowerShell scripts that they have for Windows. Originally, I was going to try and make things work using PowerShell for Mac because I hate myself. But I quickly discovered that would be a bit of a tall order simply because of the way that macOS manages system-level items like the keychain. So on Windows, you can just summon entire cryptographic certificates with like one PowerShell command. But macOS makes that basically impossible to do in a way that actually gives you something useful. And because of that, there's a good number of PowerShell commands that would work great on Windows for this situation, but they simply don't work or don't exist on macOS. So I tried looking into a pure shell implementation instead, and I got roadblocked again for a similar reason. It's extremely difficult to do work with the keychain from a shell script, especially if you're doing anything more than trying to fetch a generic password object. You want to grab the Intune workplace join key that's stored on your device and sign something with it? Yeah, forget it. So that brings us back to Swift. And honestly, all this headache is probably why macOS Labs was also written in Swift. So I have the framework chosen. Now we just need to figure out what would need to be implemented differently. An obvious first thing is the secure token or file vault functionality. On Windows, you have BitLocker, and it works at the OS level, not the user level. So you don't have to worry about user accounts having some sort of security entitlement to the file system like you do on macOS. Oh, well, why not just stop granting secure tokens to your local admin accounts, you might ask. Well, that would work if it weren't for the fact that it would get granted a secure token the first time an interactive logon takes place because Intune's got the bootstrap and it just does it for you. You don't get a choice. So functionality would need to be added to the base Windows implementation to kind of look out for that pitfall and take care of it. And another problem that came up was, yet again, certificate management. Cloud Labs is super efficient because it's designed for Intune. It uses certificates that are already laid down on the device by Intune to authenticate the device to the backend server. Now, looking around, macOS devices get a similar certificate from the Intune agent. It's the workplace join key. Great, wonderful. What's the problem then? Well, that certificate is there as long as you don't enable platform SSO. And Microsoft says this themselves in their documentation. What happens is when you enable platform SSO, it kind of does away with that certificate being anywhere usable. It gets moved into the secure enclave, and you never see it again. Thanks, Microsoft. So let's figure out something else then. What else does Intune put on a Mac that can uniquely identify the device? Well, it turns out we do get one other certificate, the Intune MDM agent certificate. It's a bit different from the Intune workplace join key because it's managed by a different certificate authority, and Intune doesn't store this information on the server side like it does with the workplace join key. But this does have a private key associated with it that we can use to sign data. We just need to find a way to make that certificate information available to Cloud Labs on the server side in the most efficient and least likely to break way possible. Now, the way that Cloud Labs usually validates a client request is it takes the device ID that you provide in the request, and it pulls the Entra device ID record with this fun API call up here. And then the output looks a little bit like this. Now, in that record, we have this alternative security IDs section, and that contains data about that workplace join certificate that you can use to verify data signed with the certificate on the client end. And the ideal solution is to find some way to chain a new certificate to the device record in a way that looks similar to this. So so if we do this, we can reuse a lot of logic from the Windows implementation. That way you don't get any weird issues if the device is reset, because it'll get re-enrolled to new device ID, and that record will be completely new. So because Cloud Labs uses device IDs and not serial numbers or device names to verify requests, We never need to worry about cleaning up old devices that get removed from the environment or reset. Intune and Entra take care of all of that for us. But when it comes to storing these device passwords, well, those are stored by the serial number so that when a help desk user goes to pull up the password, they just need the serial number. They don't have to hunt for the device ID or something like that. But back to the problem at hand, how do we store that certificate that we want to use? And some of you staring at this thing long enough may have figured it out already, but those extension attributes here are completely they're on the device record, and they're kind of a carryover from the old Active Directory days. They seldom see any use. That's actually perfect for us because we can put things here, and we can get all the advantages of self-cleanup and all that, but with a certificate that we can actually guarantee will exist on the device. So obviously, we still need to create a method to get that certificate into the device record. This required a new API endpoint on the back end to make everything happen. So what happens is the client app grabs this MDM agent certificate. That is the wrong tool. Let's try the laser pointer. There we go. So what happens is they grab this MDM agent certificate out of the keychain, and then they throw the contents of the certificate into a web request. And then to make sure everything matches up correctly, prevent any corruption in transit, the private key on the certificate is used to sign the device ID, and then that also goes into the request. And that way, when the Cloud Labs server over here processes that request, it has all the various forms of the public key, and it can convert the certificate data into something we can store in an extension attribute, so condensing the certificate information, base64 encoding it, all that. So Cloud Labs will then send that new certificate information and the expiration date of that certificate over to Entra to be stored in the device record right down here in extension attributes 11 and 12. And we throw that certificate expiration date in there so that Cloud Labs can request an updated certificate from the device when the old one expires. And to make this signaling work, we use a specific HTTP error code on the Cloud Labs backend to signal to the client device when it needs to provide that certificate information either for the first time or because the certificate's expired and it needs a new one. There we go. So this all seems pretty dense, but it actually gives us a really simple, fairly bullet-resistant way to make authentication work. We have a certificate now that we can be certain will always be there. Entra manages device housekeeping for us, and adding functionality to the client is as simple as asking for a new password, checking for an error code, and sending the certificate information if we get the right error code asking us to provide it. And if we look at the client-side code here, that's exactly how I've implemented it, actually. We try to request a new password up here with this process event transaction call. And if we get one, then great, we move on and we set it and do all the other fun stuff. But if we get this error code 412 back from the server, we know it needs new authentication info from us, so we can simply put that together right here, send it up, make sure that the server received it, and then try the password request again. So huge hurdle out of the way, pretty simple. Now we just have to sort out the actual rotation and storage issues. Which brings us to our good old friend, the secure token, once again. So remember like 4 or 5 slides ago when I said we'll get to this in a minute? Well, we finally made it there. So in a nod to the solutions that came before, I actually ended up using the macOS Labs implementation of password rotation for Catalyst. A lot of that code is the same between the two solutions. I think the biggest changes I made there were to how the client detects if the account has a secure token. Luckily for us, open directory calls are one of the things that Apple doesn't really look bent on removing from existence anytime soon. So no need to reinvent the wheel there. And then I added a ton of error handling to kind of make things a little bit cleaner. So that means, just like macOS Labs, Catalyst will seamlessly detect on every run whether or not the local admin account has a secure token or if it's file vault enabled. And then it adapts accordingly. So that means all you really need to do right now is to migrate over is create a new local admin account, set a sample password, and then delete the old local admin account. And depending on how you end up deploying Catalyst, which I'll touch on shortly, you don't have to do any extra scripting or anything to make that happen. Just set some preference file values and then roll it out. So if I didn't really do too much work on this angle, you might be wondering, hey, why did it take this idiot a year to build this? Well, to answer that question, we find ourselves returning to our good old friend, the keychain. Well, sort of, at least. Now, earlier we went over how macOS Labs just kind of throws the local admin password in the keychain with pretty lax controls to prevent a nosy user or a bad actor from trying to grab it. So I tried a couple things while looking for a solution to that problem, storing in a different keychain, storing on the file system, somehow trying to store it within the client app data. Eventually, the route I came up with was to also use the keychain, but encrypt the password object with a key that only the Catalyst app would ever have access to. What's the best way to do that, to secure that key? Well, we enlist our services of our friend, the humble Secure Enclave. Now, the term Secure Enclave gets thrown around a lot without much explanation for what it is. So if you're new to the concept, basically it's a tiny little computer in your computer that exclusively handles cryptographic operations. So everything is self-contained on that little Secure Enclave chiplet on the processor. Now, what that lets us do is use the Secure Enclave to create and store a key that we can use for encryption and decryption. Well, then why not just use OpenSSL or something and create a new key then? Well, I haven't gotten to the cool part yet. Nothing on the actual OS ever gets or sees that key that the Secure Enclave generates. So what the Secure Enclave will do is give you a representation of that key that you can hand in, sort of like an ID, to the Secure Enclave with instructions for what you want it to do. And then it recreates that cryptographic key within the Secure Enclave environment, performs only the task that you requested, and then hands you the result. And it will only ever do any of that if you provide the correct representation of the key that you want, and you are the same app that created the key in the first place. So what that lets us do is take this key representation, and we can put it basically anywhere we want without worrying about another process or user filching the key and then decrypting our password. So out of all that, the workflow we get is get a password to encrypt, ask the Secure Enclave to create the encryption key for us, encrypt the password, and then store that encrypted information in the keychain along with that representation ID from the Secure Enclave that we need later so that we can decrypt the password. Now, if someone else tries to come grab that password later, well, tough luck, it's all just gibberish. And even if someone reads up on the solution, well, they can't really do anything because the Secure Enclave has our back and will only release the decryption key to the Catalyst process. So no ACLs, nothing floating in the file system, nothing in plain text, no more security hole, problem solved. Now, I actually went and user-proofed things a little bit more as well. So because we don't need to rely on a script to pick the key up from the device, we don't need Catalyst to output anything when it gets run, and it doesn't need any extra options or arguments to function. So there aren't any extra arguments. Catalyst runs through the same process on every launch, which makes things a lot simpler. So like macOS Labs, we don't run the application unless the root user starts it, but we might want a safe way for support staff or one of those only sort of privileged users to give Catalyst a bump if something is wrong. So leveraging the same launch daemon functionality that macOS Labs has, we can give it a little bump with this launchctl start command up here. And you can monitor the exit code with the launch daemon logs for non-password issues. And for password-related issues, you can go to the web console, and it will show most password handling errors and an easy-to-understand English format in there. So if you get an error code in this launch daemon log, well, you can look it up in the documentation. You can figure out what's going wrong. So for example, maybe for some reason there's a cryptographic error when Catalyst tries to store the password in the keychain. That is actually a password-related error, so you would see that in the web console, and you can proactively remediate the issue remotely or identify it easily during a call to the help desk. So what if you forgot to set a required setting for the Catalyst client on the device? Well, that's not a password-related issue, that's a client issue. You would get an exit code in this launch daemon log with a clear description in the documentation. So this helps make the troubleshooting process a little easier, since you can kind of just ask the user to send you their launch daemon logs that they can grab in the console app, instead of trying to like dig through 8 different directories across your entire drive trying to find the actual logs that you need. So it's the big points of the entire Catalyst solution. Hopefully I've gotten at least one of you interested. Now, if you are interested, you're probably wondering either, does this cost money, or how do you deploy this? And I've got good news on both those fronts for you. Catalyst is built on open source tools, and as a result is completely free and open source as well. The only cost you pay is to run the backend on Azure. So no support contracts, no BS, no premium tier gatekeeping, the actual functionality you wanted. Deployment is easy as well. You can deploy the entire backend to your Azure tenants with just a few simple clicks in about 10 minutes of your time, and I'll go over that over here in a minute. And deploying the client app through Intune is almost as easy. So let's start with the backend deployment because it's the simplest of the two. All you need to do is head to the Catalyst GitHub repository, copy a setup command from that repository, and go to Azure, open the built-in Cloud Shell, so no authentication or anything necessary, and then paste that command in, enter literally 3 details about how you want to name the web apps and how much compute you want, and well, then you wait 15 minutes for the deployment to finish and you're done. So on your end, that's the hard part over. After that deployment completes, you just have to go find a global admin to run a second short script just to provision the app registration for Cloud Labs with the correct permissions to actually verify device information. And after that, you're good to go. All that's left is to configure who can access the password retrieval portal. And of course, there will be a full deployment guide available on the Catalyst GitHub page, kind of walking you through how to do all this, what the permission script does, kind of how everything works, just in case you're curious, or if your enterprise enforces settings that would cause an error during that auto deploy script, you can always go back and do it manually. And then if your tenant's global admin asks, hey, why are you asking me to run this sketch script that some random former college kid created? Well, you can point them to the repository and say, here, you can look at it for yourself. Now for the client app. So it's a little bit less easy, primarily because you have to deploy configuration first. So the way that Catalyst knows what settings to use at runtime is through preference files. So that allows us to set managed preferences, defining the app settings without using a script. That really reduces deployment headaches since Intune will handle putting the information on the device and updating it in the future if you make any changes. So you can find an example preference list on the GitHub repo with documentation kind of explaining all the possible preferences you can set and where to get those values that you need from and how you can take advantage of the built-in migration functionality. So the first step will be to deploy that configuration policy to all the devices you'll be using Catalyst on. I'd honestly recommend just deploying it to all of your devices because it won't hurt anything if you put it on there and Catalyst isn't installed. It just sits there. So after that, you give it a couple days for everything to settle down on all your devices before you move forward to prevent errors related to those preferences not being set when Catalyst tries to run. And then you deploy the actual app itself. So for flexibility, we actually make 2 different versions of Catalyst available for use. You can use the easy.pkg installer, which includes the migration script built in, and you just throw that into Intune as a line of business app, assign it, you're good to go. It's already signed for you, notarized, ready to use, all good. Now, if you're not migrating from something else, no worries. That migration script will be in there, but it won't do anything. The package will work just fine. If you want to, for example, put Catalyst maybe somewhere else, use a different install script, maybe you're migrating from something else, something that has a little bit more of an exotic architecture, well, we've got you there too. You can just grab the signed in notarized.app file, build and sign your own installer, and then roll it out the same way. Though we do recommend sticking with the precompiled PKG for most deployments, since it usually will just work. And of course, you're free to inspect, tweak, reuse, whatever, that install script that we throw into the precompiled PKG at any time on the Catalyst GitHub page. The only thing we don't give you here is our signing keys. I hope I don't have to explain why. So how well does this work in a real-world environment then? Well, I went ahead and guinea pigged this on, well, in our entire Mac environment, actually. We started rolling this out to all production devices a couple weeks ago after a limited 200 device pilot. So our total deployment footprint right now is about 1,600 devices. We've only had about 15 devices have a consistent failure due primarily to a rare keychain bug that I am working on fixing. Overall, though, that is a much lower failure rate than we had on macOS Labs. And now we have the easy visibility to spot those issues from the web panel before the user makes it our problem, and we can take action proactively. And I'm actually so confident in how well this is working that I'm going to do a little bit of gambling here, both with my poor AT&T hotspot here and our actual production environment. And I'm going to show you that Azure workbook that I showed you guys earlier with the admin dashboard. I am brave, and this is probably, we'll see if this is a good idea. All right, so you have this blank screen here because I don't know how to use macOS. All right, so you have this log analytics workspace here. Setting this up is actually currently separate from setting up the backend, but it is really easy. You just import a JSON file, and this kind of does the rest for you. So you have the admin dashboard here. You can kind of track the last time any of these logs were updated, and you're able to actually keep track of the last check-ins from all your devices in your environment. So on every check-in, you will get some message all the time. So what you'll see here is this is the date that the device checked in, the device's serial number, and if you click this, this will take you to the actual device record in Intune. The output of the logs of the run. So we see for most of these devices, the password hasn't expired on them because I pushed this up a while ago. So it'll just send that little check-in, hey, I'm still alive, and it won't do anything else. And then here, you also have the device ID of the device record in Entra. You can keep track of the histograms, kind of analyzing failure metrics. You'll see they kind of spike a little because some of them don't play too nice on the first rotation, but they usually settle down afterwards. And then in here, you also have device search. So you can actually take a device's serial number and pull only the log data related to that device. So here we have my device's serial number here, and you can see every time it has rotated this password and when. You can kind of keep track of that histogram up here as well. And you also have the password retrieval metrics. So that is this auditing bit that you kind of need. Let me hide this a little bit more. And you can see the date and time that a support or service provider user pulled a password for any device. It will show you what device they pulled it for, what user did it, the audit results, and the join type for the actual Azure device that they're pulling the password for, and its compliance state. And on top of that, you also, if you go back to this summary here, you can grab these little 3 dots here, and if you hit this open last run query in the logs view, this will actually take you into the log analytics tool, and you can use the custo query language to create your own logging or metrics gathering kind of reports based off the data that Cloud Labs provides. And then do this. Cool. All right. That was more painless than I thought it'd be. Yes. Cool. All right. So beyond that, well, now I've spent the better part of about an hour or so kind of basically evangelizing this thing. You know, I can't possibly have anything bad to say about it, right? Well, in any system, there is always going to be room to improve. So I'm going to touch a little bit on a couple sticking points before I let y'all go here. First off, I'll be upfront about it here. I basically learned Swift by writing this Catalyst app. So that's part of why it took so long. And while I do have programming knowledge going in, there is always a learning curve to every new language or framework you pick up. That had 2 big effects. The first is it may not be written or organized the way a Swift app is supposed to be, if that makes sense or even exists. I know Java is pretty kind of hard about that. I don't really know how it is on Swift. I tried to keep things clean down to documenting the crap out of absolutely everything, including private methods that I did not have to. But there's probably, there's always going to be parts I could have done better. And along with that, the conventional or classical way that you learn in university when you learn to code is that you're supposed to write your application tests first and then code the app to pass those tests. Well, that's what I learned when I was an undergrad, at least. Unfortunately, I got hit with a bit of a double whammy on this one. New language that I've never written tests for, and system-level changes that this app is making that you can't really test very well. It's pretty difficult to test that functionality without just running it on devices. So hopefully at some point I can circle back and try writing some test suites to prevent regressions, but that I wouldn't be able to spot in the future. But it would probably require some mock API to be built and a whole bunch of other stuff. to work correctly. So bit far off, but still on the wish list. And there's room to improve on the experience side as well. Right now, the Cloud Labs portal doesn't have a way to view those old versions of the device password, even though that data does exist in the Key Vault. So you would have to have an administrator go into the Key Vault manually and fetch it out. That's something I'd love to add or work on in the future, because while you can go in manually and fetch it out, the Key Vault GUI in Azure doesn't actually have a search tool. So it's a bit difficult in a large environment. You'd probably end up using PowerShell or the Cloud Shell commands, and nobody wants to do that. So probably not the most difficult change to make. Basically just add a drop-down that's in the option to view previous entries. But as always, it's a bit of a time management problem. And a potentially big hang-up here, at least right now, is if you're doing BYOD or personal Macs right now, and you want to use this for some reason, Intune doesn't currently push the specific certificate that I'm currently using to those devices. So Catalyst will just kind of sit there and not do anything because it can't authenticate to the backend server. It's not a particularly difficult issue. I just have to build some more detection logic in to have Catalyst choose the correct certificate for the device dynamically, and then keep track of which certificate it's actually using on every run. So coming soon, but it might be a couple weeks, just something to be aware of. And now here's how much the entire backend costs to run on our Azure tenants with an older version of the Cloud Labs backend deployment. So this is as of last month. If your budget's on the smaller side, you're probably thinking this might look a little bit high, but I have some good news on that front. I was actually playing with the deployments a couple days ago, and Microsoft has actually given us a couple new ways to provision function apps. That's what the backend uses. So where in the past you had to have your function app backend and the web app portal on their own compute completely separate, you can actually combine the compute backend for that now. So the function app and the Cloud Labs portal can both run on one app service. So that allows you to save a ton of money, cut out a ton of unnecessary cost. So you see this functions line item down here, that would basically evaporate. So you can expect that total monthly cost on what we recommend that you use in terms of compute to go back down a little bit closer to $100, maybe less, depending on if your organization enforces Defender for storage. So the other good news is that pricing after you deploy doesn't really change when you add more devices. The Key Vault's pricing is extremely cheap, and they have a very generous free tier. So this remains really stable when you scale across your entire environments. You actually can't even see the Key Vault price here because it's so small. And for a little bit of context, we do have 18,000 Windows devices. And before we migrated, they were all using this compute and that Key Vault. So that is with 18,000 devices worth of Windows records for 2 years and the new Mac ones on top. So another way to reduce cost further would be to run everything on Linux app services instead of Windows. That's something I'm working on. The backend was built natively to run on a Windows app service. The portal app was unfortunately built in C# and would require a recompile for me to be able to move it over to Linux, and I haven't had the time to do that yet. The great thing about how this is deployed, though, is that theoretically you can simply delete and redeploy that app service plan, the web app, and the function app, and that'll allow you to take advantage of a platform switch in the future. So if you deploy it now, and I somehow make this like half the cost, I won't. Okay, it's already pretty cheap. If I can somehow halve the cost, you can just run the update deployment, and you can take advantage of those features immediately. So the nifty thing about that kind of transition is that the client app won't break because you're updating the backend. It'll just kind of try to check in. It'll see that your servers are down. It'll go, and then it'll exit without doing anything. So no changes are made, and it'll just check in later to do a rotation. So pretty easy, and as long as you don't delete the Key Vault that contains your device secrets, you're okay. And please don't do this, but even if you do delete the key vault, Azure uses soft delete by default for key vaults, so you can actually go and resurrect that key vault with all of your data still intact within 90 days of deletion of that resource. And last thing here, do we really need to use the keychain to store everything? Well, honestly, no. The data is encrypted either way. It's just easier to let the OS, for now, take care of storing it. But if Apple keeps insisting on ripping apart their keychain APIs like they have been over the last decade, it may end up becoming necessary to kind of move to the file system or another way to store this data on the device. So to get around the keychain deprecation quirks that you saw with macOS Labs, with Catalyst, we actually let the OS decide where to store the keychain objects instead of forcing open the system keychain and saying this can only go here. Now, Apple does have the iOS data protection keychain. I did try it. Unfortunately, it is tied to the logged-in user, so storing there causes a lot of access headache. When you're trying to work with a launch daemon, it basically doesn't work. Apple's been trying to kind of push this iOS data protection keychain on macOS for the better part of a decade, but they don't really seem inclined or motivated to solve the access issues that are preventing everybody from actually migrating there. They don't seem any more motivated to solve the issue than they were in 2014, so I'm not holding my breath for that to get any better. And apparently neither are Google or Mozilla, because they have this same exact issue with their web browsers. And Apple simply doesn't really seem to care. The good news is it's pretty easy to migrate things over to the file system if Apple fully cuts support for the system keychain. So this is more a thing to look out for going forward than something that needs to be actively fixed or improved. And with that, we have made it to the end here. So thank you all for staying awake through this. I know it's 9 a.m. on a Friday. You guys are probably just trying to get on a plane and get out of here. I know parts of this were dense, so hopefully I've left some time here for any questions. I appreciate you guys sticking with me through this. I hope it was useful to at least a couple of you. Feel free to connect with me on LinkedIn. That is right here, or you can scan this nifty QR code and you can get that information. The Catalyst GitHub is live now. It is in a pre-release state right now, but if you want to take a look at it, you can get to it with this QR code over here. It's in pre-release while I finish up the deployment scripts, so those aren't live yet. I'm working through a couple last things related to moving all of the compute into one thing, so it takes a minute. It should be done in about a week, though. I'm almost there. I think I have 1 or 2 bindings left to set. So before I open up the questions, I did also want to say thanks to the wonderful folks at the Mac Admins Foundation for offering me the first-time speaker grant that I was able to use to come out here and present this to you guys. When I told my employer that, hey, I'm going to submit a proposal to present at Mac Admins, they were like, great, good for you. We are not paying for it. I'm like, okay. So I really appreciate the opportunity this provided, both for my professional growth. This is my first out-of-state conference, and for me to show this to the world. Now, it's Catchbox time. Anybody got any questions? All right. There you go.
So I guess the password, the lapse
Yes.
Password cycling change, the I guess rules are different depending on what you're using. I wanted to find out, maybe you mentioned it, but like I wanted to find out what Catalyst specifically is using. Like, is it a set time frame that the passwords get cycled, or do you not cycle it unless it gets pulled? Mm-hmm. How does it exactly work?
So that's the cool thing, is it's actually user adjustable. Not user, but you can adjust it. Mm-hmm. So I can actually go and show you guys if Xcode will play nice with me today. So if we go in here and we go and we look at this info, not that one. Technical difficulties, just 1 second. There is an info.plist.example in here, and it is going to be updated. It is into a format that Intune can use, but you can actually set this days to expiration key here. This is one of those required values, so it won't run unless you set this value. There's no fallback, so you can set it to 0 if you want it to update on every check-in. The way we have it set up in our environment is we have it set to 3, so it'll check in every 90 minutes because of the launch daemon, but it will only cycle the password every 3 days. So that allows you to keep the device heartbeat, make sure that your device actually is still alive and the app is functioning correctly, while still having it rotate on a schedule that doesn't hammer your backend server.
And is it adjustable so say we set the set days for 3 days or 5 days, right? But do we also have the option to, if nobody touches it, right, it rotates in 5 days. But if somebody pulls the password, it'll update in a few hours or the next day or something like that.
Currently, no. That would require a communication from the backend to the client, which is a little bit more difficult. What you can do, though, is my most recent revision that I have up on GitHub, I believe. We have it deployed in our environment. This is all done with launch daemons, right? Mm-hmm. So the regular automated run has its own launch daemon. It runs every 90 minutes or so. We actually added another launch daemon on top of that is triggered manually. Unfortunately, it does have to be run with elevated privileges, so you would have to be in the machine as that admin user in order to initiate that rotation, which you could still do during a remote session if you're a service provider, or you can check the logs to make sure that the user actually did it before you terminate a support call.
Well, what I meant, for example, couldn't we do it? So, for example, you're getting the password, like your team gets the password, right, mm-hmm. to get to the user in the first place. So that could be the trigger that shortens the time frame for updating it, is what I mean. It could,
yeah. The problem there is around how Catalyst communicates with the server. Everything is initiated by the client. To do what you're describing, I would love to, actually. That's a great suggestion. But it will require that the server reach down to the client, which kind of changes things a bit. Because right now, the way it works is the client is kind of blind to the actual server. So it can send out, but it can't receive.
Okay. Anybody else?
Yeah, so just like adding on what he said, could you do something like a webhook or something like that where the client is sending something out to the
Probably,
server?
Yeah. It would have to be, something to look into. I do love the suggestion, though. I kind of played around with it a little bit in the early days and then gave up trying to figure everything else out. Again, first Swift application, I kind of built the plane as I was flying it here. Sure. Yeah. It is a great suggestion, though, and it is, webhooks are probably a great way to do it, something I can kind of look into in the future.
Yeah. I actually did have another question, too. What happens if you try to run this on an Intel Mac?
This is compiled as a universal application, and the way it works, I believe, those certificates, not the certificates, you're probably worried about the secure enclave at that point. There is actually, so if we go here to library secure key, what happens is in a different one of these other files, during that rotation process, it will say, does this Mac support secure enclave? If it does, is use secure enclave enabled in the managed settings? If it is enabled and it is supported, it will use this secure encryption class, which actually interacts with the secure enclave to generate that key pair. If for some reason the secure enclave is not available, if it's not supported, so if you're running an Intel Mac, or if you have it turned off for some reason to debug or what have you, it will actually fall back to this insecure encryption class, which is really more designed just to keep a nosy user from getting their hands on the key. So what this will do is it will take the serial number of the device, it will compute a SHA-256 hash of that serial number, and then it uses that serial number to generate the encryption key. That way you don't need to store it anywhere, it'll just kind of figure itself out every time. Obviously, it comes at the cost of security, but for backwards compatibility, it's really the only option.
Cool.
That shouldn't be a problem for much longer.
Oh, I hope so.
Yeah, right.
And again, all of this is thoroughly documented with SwiftDoc. So if I actually go here and I can build the documentation and show you guys if Xcode doesn't take 8 years. There we go. So if you go here, you can actually look at the docs for the insecure encryption, and you do have this big warning plastered all across it that this is not actually safe and is only really done to prevent nosy users from looking at their key. Anything else? All right, well, hope you guys enjoy the next one session of this conference and then lunch, and I hope you all have a safe flight or drive or travel home.